Hi everyone, in this section we will be starting with the first tutorial, how to create a project. For the first part we will be creating a simple LED blinking project. So now to create a new project you have to go to the file, new, STM32 project. So this is the window which is asking us about the microcontroller, microprocessor or the board which we are going to use in this project. So I have clicked on the board selector and now I have to give the information of my board. So here as soon as I enter STM32F407, an option comes to me by which I can actually choose the name of my board. So I have chosen the name of my board STM32F407 disk 1, and if I click on it I can see the details about this board, which is true in my case. So I have to click on the next button, and now we are coming into a window which is asking me for the name of the project I would like to give. So here I have given the name of my project as F4 underscore LED underscore blink underscore 1, and then we have got some options over here. The first option is which programming language we will be using in this project. I have chosen C. The second part is the target binary type which will be made out of this project is executable or static library. I have chosen executable, which is an ELF file. And the third part is target project type. So in this one we can use STM32 cube or as an empty. In this case we will be using STM32 cube because I want to show you the graphical user interface provided by STM32. And now I will be clicking on the finish. Now it's asking me, do I need to initialize all the peripherals in the default mode of this of the given board which we are using STM32F4 board. So I will choose no. This is the STM32 graphical user interface and we can see many tabs opened over here. So the first one is pinout and configuration. In this we can actually see all the pins provided with STM32F4 device, and by clicking on each of the pin you can actually initialize it to input, output or as an alternate function. So now we have got a clock configuration over here. I click on clock configuration. Here we can see three types of clock have been provided to a board. One of the clock is PLL, which is phase lock looping. Another one is HSE, which is high speed external clock, and the one which we are using in this project is HSI, which is high speed internal clock. The HSI in our case is 16 megahertz. This clock is provided inside the microcontroller, and you can see this HSI is used to derive system clock, edge clock and peripheral bus clocks. So the question is, what does 16 megahertz mean over here? So in simple words, each instruction of microcontroller unit runs at 16 megahertz, or it uses 0.0625 microseconds to execute it. So here we can also see that 168 megahertz is the maximum frequency supported by this device. So to make it 168, we can simply write 168 over here, but it won't be possible because the original frequency provided by HSI is 16 megahertz. So for that we have to switch from HSI to PLL. And now if we enter 168 and press enter, now you can see that 16 megahertz clock is going from here to this multiplexer, which is divided and further multiplied, and which is finally giving us 168 megahertz. So by doing these steps we can increase the clock from 16 megahertz to 168 megahertz. However, we don't require such a high speed clock at the moment, so we will be switching back to 16 megahertz. So for switching back to 16 megahertz, we will highlight this one and press enter. So now it's on 16 megahertz, but it will be simpler if we just use HSI directly, and its prescaler is 4, so we'll make it 1 and we can see it's back to 16 megahertz. So now back to pinout and configuration. Now we have to configure one of our pin as LED. For doing that we have to refer to the user manual provided by STM32F4. So this is the user manual by STM32F4. Here we can see 4 LEDs are supported on this board. To learn a little bit more about them, we have to go to hardware and layout. Here we can see that there are 4 LEDs. The 4 LED provided on this board are green LED, blue LED, orange and red. For example, in this tutorial we can refer to green LED, which is LD4, and which pin it's corresponding to. For that you have to go to LEDs under hardware and layout, and here you can see green LED, which is LD4, is PD12. So now back to pin and configuration page. So we will search for PD12, this is the one, and here we will make it simply GPIO output. We will be saving the project now. After saving the project, the codes are generated automatically, as we can see on the screen. So now you can see this IDE window, which is having the codes for us, and this IOC file is the same one which we were using for graphical user interface for STM32. So here you can see the project is created for us. Under core directory we have include directory and source directory. In source we have main.c. In main.c we have different initialization functions and forever while loop. So now to make any changes in IOC file, which was the graphical user interface which we saw just few seconds before, we have to make sure that whenever we make any changes into that, we do not lose whatever we have written into this code section. To ensure that STM32 provides us with special comments where user codes are starting and ending, so whatever we write inside them, they won't be lost. To explain it, I will be creating two variables, one inside the comment and one outside the comment. I've created these two local variables, uint a equals to 1 and uint b equals to 1. The only difference between them is that one is defined before the comments, one is defined after the comment. Now if I save it, now I will be opening my IOC file. I'm making a quick change in my PD12 pin from output to input, input to output, and then saving the project again. You can see that whatever was defined before the beginning of the comment is deleted. So this was an example to show where to write user codes and to avoid the deletion of them in the case of changes. So now back to LED project. So now we will be writing 1 in the output pin. So for that, there are already some functions made by the HAL hardware abstraction layer. So to do that, we will write HAL underscore, and then we will be pressing Control and space. So it's a shortcut which will actually be showing us all the methods defined by HAL. There is an option HAL underscore GPIO underscore write pin. So if we select this one, it is asking us about the port, the pin, and the pin state. Here we have defined port as port D, pin 12, and pin state as set, which is 1. To further investigate pin set, we can right click on it and we can go for its definition, where we can see it's a part of a enum where pin set is set to be 1 and pin reset is set to be 0. Now if we visualize the program tells us that when the main function is called, initialization of the pins and configuration of the clock is done, and after that in line number 94 the pin number 12 of port D is set to 1 before entering to the while loop. If we further look into another function such as sysclockconfig, we can see it has been configured with HSI, which is high scale internal clock. This we have already seen clock and configuration part. Now if we browse a little bit more, then we can see there's another initialization function for GPIO. If we browse a little bit more into it, then we can see the first time when this pin is actually initialized, which is port D pin 12, it is set to reset, which is number 0. So it is initialized with 0, and then we are manually configuring it to number 1, which is set. And this is all what's happening in the main.c file. Now to build the project, either you can click on the hammer sign over here, which is a shortcut, or you can go to the project and you can choose build project. So once I choose the build project, it's compiling and it has been compiled. Now to debug it, you can either click on the shortcut or you can go to the run. And if you click on debug for the first time, if you're debugging it, then it will ask you for the options. So basically the debugger has different options. One can make changes in debug probe. However, in this part we are all okay, so we have to simply click on OK button. By default all the settings are okay. Now we are in debugging mode, and now we can create a breakpoint at line number 94 by double clicking on it. When we run the program by clicking play button, we can see that the program is stopped at line number 94. We can see that the LED on the board is not turned on yet. Now if we run the program ahead by clicking on play button, we can see the LED on the board is glowing. If you have reached till this point, then congratulations, you are done with this part. In upcoming parts, we will be dealing with LED blinking by using interrupt and polling methods. Thank you.